Good morning, students. Today I am going to discuss the apparent weight of a person in a lift when a lift moves up or down. So here we will discuss the different cases. In first case, here when the lift is moving upward or downward with a uniform velocity. So case first is when lift is moving up or down with uniform velocity. Because the lift is moving with uniform velocity in upward or in downward direction, then the acceleration on the man will be 0. In this case, a is equals to 0. So the net force on man will also be 0. Now F is equals to R minus mg, or from here we can say R is equals to mg. This means in this situation the apparent weight will be equal to actual weight. Apparent weight will be equal to actual weight. Means because a lift is moving upward or downward with uniform velocity, then there will be no change in the weight of the man which is traveling in the lift. Now discussing the second case, in which lift is moving in upward direction with acceleration a. Lift is moving with acceleration a in upward direction. Upward direction. Then in this situation the net force on the man F will be equal to ma, and from the free body diagram we know that the force is acting in upward direction. So the force is equals to F is equals to R minus mg. Equating these two equations, ma is equals to R minus mg, or R is equals to m a plus g. This means R is greater than mg. So in this situation the man feels that his weight has increased, and the value of apparent weight will be equal to apparent weight is equals to m g plus a. So when the man inside lift goes up, then apparent weight of a man inside lift will be more than the actual weight. Now coming to third situation, in which the lift is moving in the downward direction with acceleration a. Lift is moving with acceleration a in downward direction. Downward direction. Then the net force acting on man will be F is equals to ma, and from the free body diagram the net force acting in downward direction will be equal to F is equals to mg minus r. Now equating these two equations we will get, or r is equals to m g minus e. So in this case the man feel that his weight has decreased. Means the lift, as the lift moves down, then the apparent weight of the man inside the lift will be less than the actual weight. Now coming to next situation, in which the lift fall freely. Lift fall freely. When the lift fall freely, then in this situation the acceleration becomes equal to acceleration due to gravity, and the force F is equals to mg minus r, or F is equals to mg. Equating these two equations we will get mg minus r is equals to mg, or r is equals to 0. In this situation the apparent weight of man becomes 0, because both man and lift are moving downward with the same acceleration. So there is no force of action or reaction between the man and lift. Hence the man develops a feeling of weightlessness. This situation is also known as weightlessness